The Big Bang Theory, the universe's biggest party. Alright, picture this. About 13.8 billion years ago, the entire universe was smaller than the tiniest speck of dust. Then boom! It exploded outwards faster than you can say cosmic expansion. That's the Big Bang Theory in a nutshell, folks. What's the big deal about the Big Bang? 1. It all started with a bang, obviously. Imagine squeezing everything in the universe into a tiny point. 1. Now let it explode. 1. That's basically what happened. 2. It was hot, hot, hot. We're talking temperatures hotter than your spiciest hot sauce multiplied by 1 billion. 3. Everything was soup. For a while, the universe was just a mix of super hot particles floating around. 4. Things cooled down. As the universe expanded, it cooled off, allowing atoms to form and eventually create stars and galaxies. 5. We're still expanding. Yup, the universe is still growing, like a balloon being blown up in slow motion. The Big Bang timeline, a cosmic recipe. 1. Start with one universe-sized point, eoseconds. 2. Add a dash of rapid expansion, up to 10 to the power minus 32 seconds. 3. Sprinkle in some quarks and leptons, 10 to the power minus 10 to 10 seconds. 4. Mix in protons and neutrons, 10 seconds to 20 minutes. 5. Let atoms form, 380,000 years. 6. Slowly stir in galaxies and stars, 380,000 years onwards. 7. Voila! 7. You've got a universe. The Big Bang's biggest fans. 1. Georges Lemaitre. This Belgian priest was the first to say, "Hey, maybe the universe is expanding." 2. Edwin Hubble. He looked at the stars and said, "Yep, they're definitely moving away from us." 3. George Gamow. This guy predicted we'd find leftover heat from the Big Bang. 3. Spoiler alert, we did. 4. Arno Penzias and Robert Wilson. These two accidentally found the heat Gamow was talking about. 4. Eureka. Big Bang bonus round. 1. Cosmic inflation. Imagine the universe's expansion on steroids. 1. That's cosmic inflation. 2. Quantum fluctuations. Tiny hiccups in the early universe that led to galaxies and stars. 2. Thanks, quantum weirdness. 3. Dark energy. The mysterious force making the universe expand faster and faster. 3. It's like cosmic coffee. The steady state theory. The universe's endless party. Before the Big Bang theory became the cool kid on the block, there was the steady state theory. It said, hey, what if the universe has always been here and always will be? Steady state in a nutshell. 1. The universe is infinitely old. No beginning, no end, just vibing forever. 2. Matter is constantly being created. As the universe expands, new stuff pops into existence to fill the gaps. 3. The universe looks the same everywhere. Whether you're here or 1 billion light years away, it's all the same cosmic soup. Steady state all-stars. 1. Fred Hoyle. This British astronomer was the steady state theory's biggest cheerleader. 2. Herman Bondi and Thomas Gold. These guys helped Hoyle come up with the idea. Why steady state lost its groove? 1. We found the cosmic microwave background. This leftover heat from the Big Bang was a big problem for steady state. 2. Quasars were more common in the past. This showed the universe was changing over time, not staying steady. 3. The amount of hydrogen and helium fit better with the Big Bang. Sometimes it's all about the elements. The oscillating universe. Cosmic yo-yo. What if the universe is like a cosmic yo-yo, expanding and contracting over and over again? That's the oscillating universe theory. Oscillating universe 101. 1. Big Bang, then Big Crunch. The universe expands, then collapses back on itself. 2. Rinse and repeat. This cycle happens over and over, forever and ever. 3. Maybe the laws of physics change. Each cycle could have slightly different rules. Oscillating universe VIPs. 1. Alexander Friedman. This Russian physicist first said, hey, what if the universe bounces? 2. Richard Tolman. He took Friedman's idea and ran with it in the 1930s. 3. Paul Steinhardt and Neil Turok. These modern physicists gave the idea a 21st century makeover. Why the oscillating universe might not work. 1. Entropy keeps increasing. It's like trying to unscramble an egg. 1. Each cycle gets messier. 2. Dark energy is pushing everything apart. It's hard to crunch when everything's flying away from each other. Eternal inflation. The never-ending bubble bath. Imagine the universe as a giant bubble bath, with new bubble universes constantly popping up. That's eternal inflation. Eternal inflation explained. 1. Inflation never stops. Some parts of the universe keep expanding super fast forever. 2. Bubble universes. New universes pop into existence like bubbles in a cosmic jacuzzi. 3. Multiverse madness. Our universe might be just one bubble in an infinite ocean of universes. Eternal inflation enthusiasts. 1. Alan Guth. This American physicist came up with the idea of cosmic inflation and then thought, why not make it eternal? 2. Andre Linde. He independently came up with eternal inflation and has been bubbling with excitement ever since. What eternal inflation means for us. 1. Infinite possibilities. There could be universes out there with totally different laws of physics. 2. We might be special, or not. Our universe could be perfectly tuned for life, or we might just be in one of the few bubbles where life is possible. Quantum fluctuation, the universe's magic trick. What if the entire universe popped into existence from nothing, like a magician pulling a rabbit out of a hat? That's the quantum fluctuation theory. Quantum fluctuation for dummies. 1. Even nothing is something. In the quantum world, empty space is full of tiny particles popping in and out of existence. 2. The ultimate fluctuation. Our whole universe might have been one of these particles that decided to stick around. 3. It all balances out. The positive energy of matter might be perfectly balanced by the negative energy of gravity, so the universe is like a cosmic freebie. Quantum fluctuation fans. 1. Edward Tryon. This American physicist first said, hey, maybe the universe is just a big quantum hiccup. 2. Alexander Vilenkin. He came up with math models to show how universes could pop out of nothing. Why quantum fluctuation is tricky. 1. Quantum mechanics is weird. We're still arguing about what it all means at the tiny scale, let alone the universal scale. 2. Size matters. It's one thing for a particle to pop into existence, but a whole universe? 2. That's a big leap. String theory and the multiverse, cosmic guitar strings. What if everything in the universe was made of tiny vibrating strings? Welcome to string theory. String theory simplified. 1. Everything is made of strings. Imagine the universe as one big cosmic guitar, and everything is made of its vibrating strings. 2. Extra dimensions. There might be more dimensions than we can see, all curled up super small. 3. M theory. This is like string theory 2.0, with 11 dimensions instead of just 10. String theory superstars. 1. Michio Kaku and John Schwartz. These guys helped develop modern string theory in the groovy 60s and 70s. 2. Edward Witten. He came up with M theory, uniting different flavors of string theory. The multiverse connection. 1. Many possible universes. String theory allows for tons of different universe setups. 2. Brain worlds. Our universe might be a 3D sheet floating in a higher dimensional space. Why string theory is tough. 1. We can't test it yet. The theory makes predictions we can't check with our current technology. 2. The math is super hard. Even geniuses struggle with the complex equations of string theory. Holographic universe. Reality as a cosmic projection. What if our 3D universe is actually a projection of information stored on a 2D surface, like a super advanced hologram? Mind blown. Holographic universe 101. 1. Information on the edge. All the info about our 3D universe might be stored on a 2D surface at its boundaries. 2. Like a cosmic hologram. Just as a 2D hologram can look 3D, our universe might be a 3D projection of 2D information. 3. It's all about information. This idea comes from thinking about how information behaves in black holes. Holographic heroes. 1. Gerard et Hooft and Leonard Susskind. These physicists first proposed the holographic principle. 2. Juan Maldacena. He came up with a specific example of how this holographic idea might work. What it means for us. Shun. Reality might not be what it seems. If this is true, space and time might be illusions. 2. It could solve some big problems. The holographic principle might help us understand black holes better. Simulation theory. Are we living in the Matrix? What if our entire universe, including you and me, is just a super advanced computer simulation? Welcome to the simulation theory. Simulation theory explained. 1. Advanced civilizations could create universe simulations. As technology gets better, we might be able to simulate entire universes. 2. We might be in one of those simulations. If it's possible to create universe simulations, Odds are we're in one. 3. Reality check. Everything we think is real might just be really good virtual reality. Simulation supporters. 1. Nick Bostrom. This philosopher laid out the argument for why we might be living in a simulation. 2. Elon Musk. The Tesla and SpaceX guy thinks there's a good chance we're in a simulation. Why simulation theory is controversial. 1. No proof. We don't have any evidence that we're in a simulation. 2. It would take a lot of computing power. Simulating an entire universe in detail would need one heck of a computer. Wrapping it up, the cosmic mystery continues. Woo! We've been on quite a journey through the cosmos, haven't we? From the Big Bang to the possibility that we're living in a simulation. We've covered some mind-bending ideas about how our universe might have come to be. Here's the thing, we still don't know for sure how it all began. The Big Bang theory is our best guess right now, backed up by a lot of evidence. But science is always changing, always questioning, always looking for better explanations. Each of these theories tells us something about how we understand the universe and our place in it. They're like different lenses we can use to look at the biggest questions of all. Where did we come from? Why is the universe the way it is? What's our place in it all? The cool thing is, we get to be part of this cosmic detective story. Every new discovery, every weird quantum quirk, every distant galaxy we spot could be another clue to solving the mystery of our universe's origins. So keep looking up at the stars, keep asking questions, and keep wondering about the big mysteries of the cosmos. Who knows? Maybe you'll be the one to come up with the next big theory about how it all began. Remember, in the grand cosmic scheme of things, we're all made of star stuff. We're the universe's way of exploring itself. And that, my friends, is pretty awesome. Until next time, keep being curious, keep exploring, and keep reaching for the stars. This is Watch Science, signing off from our cosmic journey. Stay wonderful, everyone.